So finishing off this page, let me erase so I can have room to work. So for these next two, for number 4 and 5, it would be really useful for you to draw a picture, even just putting down little X's so that you could see the size of the matrix to understand what is possible. So for let me make it bigger here. So for this one here, it's a 5 by 4. So you know that means 5 by 4. Okay, and I'm just going to finish putting in the X's. So we're looking to see how many pivot columns does it have to be linearly independent. So linearly independent, you know it has to have a pivot every column. Okay, pivot every column. Okay, let's try it. There, and there, and there, and there. Hey, look at that. That's 4 pivot columns, right? So it does have 4 pivot columns. And then it's linearly independent. Okay, all good. All right, let's try the other one right below it. And so this one here is a 5 by 6 matrix. So 3, 4, 5. Okay, then we got to go 6 across. 1, 2, 3, 4, 5, 6. Okay, so I'm just going to fill it in. I know it seems silly to have to draw all the X's, but it's going to help, I think, to know what is going on. Okay, so how many pivot columns in order to span? So we know span means a pivot every row, right? Span, pivot every row. Okay, so can I get a pivot every row? Pivot there, pivot there, pivot there, pivot there, pivot there. Wow, it kind of looks like I get a pivot every row. Okay, let's continue to read the question. How many pivot columns? So pivot, oh, there's only 5, right, out of the 6. Hey, wait a second. Span are 6. So let's remember context. So aren't the columns, so the columns of this matrix are in 1, 2, 3, 4, 5, are 5. So they have 5 entries. So the question is saying, can I take a linear combination of something with 5 entries? So, oops, go away. So can I take a number, like I'll just say 2 times something with 5 entries, and then, add on other combinations to get to something with 6 entries. Can I do that? No, I can't get to 6 entries. Right, 1, 2, 3, 4, 5, 6. I can't use something with 5 entries to get to elements with 6 entries. So the answer to this is not possible, right? It is not possible. Okay, so I wanted to just add on one other idea about when a row of zeros means infinitely many solutions and when it doesn't, right? So let's talk about that. So if I get, okay, so if I have an AX equaling a 0, let's say, and so let's say it's, when I reduce it, right, and I'm going to remind myself that it's a 0, 0, 0, 0, 0, like that, right? Okay, so if I have a pivot here, and then a 0, 0, and then I have a 0, a pivot here, and a 0, and then a 0, and a pivot here. Oop, not there. Oops, one more over, right? 0, pivot here. And then I have 0, 0, 0, 0, 0, 0. Wow, 2 rows of 0. That must mean there's a free variable, right? No, you have to always take into account context. So the matrix A, let's try to get a different color here. The matrix A would be like this, right? So the matrix A, and this is the augmented with 0, the matrix A has 3 columns. And so how many variables does that mean? I have 3 variables, one for each column, right? Because this would have an x1 in front of it, this would have an x2, and this would have an x3. Well, how many solutions do I have? I have x1 is 0, x2 is 0, x3 is 0. So here I get only the trivial solution. And so that would mean the columns of A, right? This would mean the columns of A are linearly independent because I have a pivot every column. So it's like having, this would be a situation if you were just looking at regular number of equations and number of unknowns. This is giving me 1, 2, 3, 4, 5 equations and 3 unknowns. It's kind of overkill, right? If I have 3 unknowns and 3 equations, I could do it. So 5 equations and 3 unknowns is overkill. So these are just, this means that these 2 were just extra information, extra info. Okay, so when does it mean I have, when I'm looking at a matrix with AX equals 0, where I do get a conclusion that it is a free variable. So if I have AX equals 0 and my augmented matrix gives me, oops, come back, gives me, okay, gives me a pivot, 0, 0, 0, 0, 0, pivot, 0, 0, 0, and then 0, 0, 0, 0, 0. Okay, so if I'm saying that this is the augmented, whoops, need my hat there. This is like this, right? So that means this is my A. So if that's my matrix A, I have 4 variables, right? 4 variables, because there's 4 columns in the matrix A. How many basic variables do I have? I only have 2 basic variables because they come from the pivots. Oh, so that means I have 2 free variables. So context matters. Always look for number of variables.